Explaining Magnesium by Silas Baker. What is magnesium? The eighth most abundant element in nature, magnesium, as well as 2.4% of Earth's crust. Due to its high reactivity, it does not occur in a native state, but instead is found in a variety of compounds in seawater, brines, and rocks. Magnesium is a silvery white colored metal similar in appearance to aluminum. Magnesium has a density of only 1.738 grams per cubic centimeter, making it the lightest structural metal. In its pure form, it doesn't have sufficient enough strength for most structural applications. However, with this being said, the addition of alloying elements, which means adding it to a base metal, helps improve their properties so that both cast and wrought magnesium alloys are used widely, more specifically in cases where lightweight and strength are needed most. How it's made. Extraction methods. The metal magnesium is mainly made with two processes, one of which is extraction methods, specifically electrolysis of magnesium chloride and thermal reduction of magnesium oxide. Electrolytic processes consist of two steps: the preparation of a feedstock containing magnesium chloride, then the dissociation of the compound into magnesium metal and chlorine gas in electrolytic cells. Thermal reduction is where magnesium oxide is reduced using silicone or aluminum at high temperatures. This method, being less efficient than electrolysis, has become more economically maintainable in certain regions due to lower labor and energy costs. How it's made. Casting methods. The second of the two processes is casting. Once the magnesium alloys are extracted, they have to actually be formed into something using casting. Magnesium can be molded using various casting methods for shaping magnesium alloys, including die, sand, and investment casting. First, the most widely used casting method, die casting. This method consists of forcing molten magnesium into a mold at high pressure, which allows for the production of complex shapes with high accuracy. Die casting is used the most because of its efficiency and ability to produce lightweight components. The traditional method, sand casting, includes using sand molds to create magnesium parts. Now it's evolved to include self-hardening resin sands to improve quality of casting and reduce the harmful emissions during production. Also known as the lost wax method, investment casting involves creating a wax model, coating it with a refractory material, and then melting away the wax to form a mold for casting to create a high precision and surface finish. Why it's made. The best use by far of magnesium will have to be as an alloying element in aluminum. In amounts ranging from less than 1 to 10%, magnesium enhances the corrosion resistance as well as the mechanical properties of aluminum alloys. Magnesium also tends to be applied electrochemically, as its electronegative nature makes it useful in dry cell batteries. These dry cell batteries are mostly used in military and rescue equipment, combining their lightweight, long storage life, and high energy content. Magnesium is also used in military pyrotechnics and has found numerous uses in incendiary devices and flares. In the form of finely divided particles, it has a fuel component, specifically in solid rocket propellants. The compounds of magnesium, interestingly enough, form a very important group of chemicals. Its best known medical compounds are milk of magnesia, or magnesium hydroxide, used as an antacid or mineral supplement to help maintain the body's magnesium balance. The hydrous magnesium sulfate, popularly known as Epsom salts laxatives, and farmers use magnesium oxide as a mineral addition to cattle feed in the start of grazing season. History. Magnesite is actually what magnesium is named after, coming from the ancient Greek region of Magnesia. It was first produced by Humphrey Davy when he made a magnesium amalgam in 1808, then it was off. French scientist A.A.B. Bussy produced metallic magnesium in 1828, then Michael Faraday went to achieve magnesium electrolysis in 1833. Industrially, it then started gaining recognition, with industrial production starting in Germany in 1886 with the use of molten carnallite. Later on, I.G. Farben would advance large-scale magnesium chloride processing, alloy development, and major applications, mainly for aircrafts and automobiles. In World War II, the US, UK, and Canada all expanded their own large-scale production including Dow Chemicals' seawater base extraction and the pigeon thermal reduction process. After the war, civilian use grew, and the processes were improved with heating, dehydration, and advanced electrolytic technologies. By 2019, China was dominating the global production with about 85%, having Russia, Kazakhstan, Israel, and Brazil supplying a large majority of the rest. And here are my sources. Thank you.